experience with IdaPro. So I'm going to open the file. Okay, it says number 1, what is the address of DLL main? Well, it went in a graph mode, so I'm going to press spacebar. And DLL main is right here. 1000 D02E is the answer. That's the address on all the lines starting from, let's see, like right up here where the comments are, and all the way down to right here, which is the first instruction. Okay. Use imports window to browse to get host by name. Where is the import located? So I sort by name, and it sorts uppercase alphabetic first, and then symbols, and then lowercase alphabetic. So if I double click on it, it's located at idata 1001 63cc. Yep. Okay. 3. How many functions call get host by name? And what you can do is Control X. So we see the number of functions, and I'm going to sort by address. So anything that has the same name I count once. So it's 1, 2, 3, 4, 5 different procedures are called 9 times. Focusing on the call to get host by name located at 1017.57. Can you figure out which DNS request will be made? So let me cancel out of here and go back to, let me hit back button up here. That's the way you can go to the previous screen. You can hit G to jump to address, and then 1017.57, enter. Okay, something before it sets the value. So this looks like it just because it's a valid. If you look in the bottom of that pop-up window in the gray, it says bracket, this is RDO close bracket pix. So, but then it adds D. The H is simply means hexadecimal, so this is 0D. Z means D means 13. So let's go there. So if you add 13, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Excuse me. 13 starts with a P. So it's starting at pix. There's a way I can go to, I think this is where it is. So I can see the whole thing when I double click on it. Back. So this is an offset table in data. Anyway, that's the right answer concerning PIX, practical malware analysis. Question 5. How many local variables has IdaPro recognized for the subroutine at 1016.56? Okay, so basically anything that has a negative offset is a local parameter, local variable, not a local parameter. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then there's one, question 6, how many parameters? And that's 1. Now, in the book, it says 23 variables have been recognized, but that's for IDAPRO commercial, and it does say that for IDAPRO free, which is what I'm using, there are 20. So that count is correct. Use the strings window to locate cmd.exe. Strings. Functions, strings. It's over here. So, it took me a little while to find it, but it's // cmd really is. There we go. Where is it located? It's located at 1009 5B34. Let me double check that. Yeah, that's the answer, number 7. Number 8. What is happening in the area of code that references CMD? Okay, the area of code, okay. CMD data xref, this is so sweet. You can just jump right to the code. See what it's doing. I think some of the things that we're looking for are calls. That's what we want to find out. What's this calling? So I'm going to start at the beginning of this procedure and just look at all the calls. Okay. If it's something that's ambiguous, I'm going to skip over it. Get pig count. Pushing a bunch of stuff onto the stack, and usually that means there's a call. Oh, I see a call to print sprintf. That's nice information in a little pop-up window. Turns out this is a remote shell. Let's see what this does. Send. That's a key piece. Okay, I'll look for all the calls in here. Allocate. I simply don't understand exactly what that's doing. It's sending stuff from a buffer through, but how it works and what's being sent is not clear. Alright, I have to weld on that way too long. It says the code appears to be creating a remote shell session for the attacker. Examining the graph view of this function shows a series of mem compare functions that are comparing strings cd, exit, install, injection, and uptime. There are send and receive calls. We saw a send. Okay, that's all I've got for that. The same area. set. It says look at the cross references, so Control X, I think. Well, if I double click on here and then here, Control X. Let me hit back and see where I was. 1C8. Well, the move statement, I wouldn't suspect that this call, so that's gets version information. That's what that looks like. Call vsget version. The answer is it's getting Windows version. A few hundred lines down. A series of comparisons to compare strings. What happens if the string comparison robot work is successful? Okay, I'm going to type G and then go to that address. Robot work. I'm going to go to strings and look for robot work. There it is. Double click on it. Go to this reference right here. It's right here. So, if it's equal to robot work, that means I'm not really sure what S is. Extended base pointer plus S. I just go into the subroutine. Okay, this procedure. Well, what this procedure does is it reads a key, its current version, and further down it reads a key with the value of work time, and then does sprintf with the work time. Okay, this is the one that transmits information. I do believe if we look for calls in here, call send, call free. So I'm going to hit back. So this sends whatever I guess is put on the stack. EBP plus S. And then further down it says work times. Queries that value from the registry. That's printf. And it calls that socket routine to send. See what else? Closes the key and leaves the procedure, the function. Okay. That's the correct answer. The registry value is located at HKM software Microsoft Windows current version. Work time and work times are queried and sent over the remote shell connection. 11. What does PS list do? export? It's an export. One argument. Okay, it calls this subroutine. Let's see what this does. Get version information. And then it calls this subroutine. Open process, close handle. Close handle. So what else we got in here? See what kind of calls we have in here. Allocate. Probe. Call, create tool, snapshot. That's used during, I know it's used during process injection, but doesn't necessarily guarantee that process injection is happening. Okay, let me go to this sub procedure. Okay, this reads the first process in a loop. Process 32 first. I guess it has to open the process to get information about it, I'm assuming. Gets information about modules. Module file name. See what else? Close handle. And that's a big one. Call process 32 next. So that's like reading the one afterwards in the list of all processes. So this jumps back up to here. Oh, and if it's 0, if what's returned is 0, jump 0, then it exits the loop. So it's looping through all processes according to that. That's the answer. If list sends a process listing across the network or finds a particular process name in the listing, gets information about it. See, it wasn't obvious to me that it gets information about a particular process in some cases. Let me get back. I don't know what to make. All I know is I can see it's reading. There's a loop in there, and somehow it avoids a loop if you pass the process ID in there. Alright. Use the graph mode to graph cross-references for sub 1004E79. 4E79. I'm going to go to 1004E79. Just enter. Double check this. Alright, yeah. I'm going to hit Control X to get cross references. Right now I can say right click and view. Right click. Chart of xrefs from. Okay, this is what they have in the answer. On Page 498. Okay, it says which functions could be called by entering this function. Get system default language, sprintf, sub, and then the string length. That's what the answer says. Based on the API functions alone, what would you rename this function? Get language. Okay, and then how many Windows API functions does DLL main call directly? How many at a depth of 2? It says graphs, user xrefs chart. Let me go to DLL main. Where is it? View, graphs, user xrefs chart. Now this, I'm reading directly from the answer because I didn't know where. The start and end address should correspond to the start of DLL main and the end. Okay, let me go to the end address. Well, I'm going to grab this out of here. There we go. I'm going to go to the beginning of this procedure. Now, I'm going to go view, graphs, user xref chart. I'm going to go 1000D02E. Okay, it says user recursion depth of 1. What else does it say? That's it. Alright. Now it says to redo the same thing for a depth of 2. Graphs, user xref charts. It always jumps back there. What is that? I think that's what we want. It's a 2. Oof. Heck, that's nasty. It might be wrong. Oh wait, no, that's right. It says the result will be a much larger graph, which even shows a recursive vectored DLL main. Let's see what the answer to this number is. That's a tricky one. At a depth of 2, it calls a variety of APIs, including sleep, WinExec, getHost by name, and many other network function calls. Networking function calls. It's hard to even read this thing. There it is. So it comes down to this level. All the way through all these. Next. Number 14. There's a sleep call. Looking backward through the code, how long will the program sleep if this code executes? Okay, let's go to G 1000 1358. Okay. So I just happen to know because I did read the answer. I didn't know really what this was. I mean, okay, I came all the way back to this right here, and this is key. If you go here and you look at this thing, and let me go to this. See, this says, this is CTI bracket. And sure, yeah, that makes no sense. That's not a number or anything. That's text. So one would think, you know, what's going on with this stuff. But let me go back, and from the answer, what they said was, to get back one more, it adds D, which is 13 to that offset. So let's go back to that and look. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're into, look at that XOR. Is that not weird how I put that there? It's not really a XOR. If you click undefined, you can see what that is. It's a 30. And the answer is 30 seconds. And that's where it comes from. It does get you used to realizing that some instructions that came out of the assembler aren't really instructions. They're data sometimes. So let me hit back again. And it all comes from this offset. And this right here, ATOI apparently converts text to an integer. And then this right here is 1003E8H. So it multiplies that 30. And then it got off there by 1000. That's 30,000 milliseconds. And then calls sleep. Okay, next one. 15. It's called a socket. What are the three parameters? 1701. So I'm going to hit G 1701. Enter. Protocol type and AF. And what you can do, what I did was, and in the answer I think they say, look up the socket, MSDN socket. MSDN socket. So the parameters are AF type and protocol. But this is the reverse right here because this is stack. Protocol is 6. Let's go back here and look at protocol. TCP. This is it, and I tried to select it and say OK. Isn't it supposed to put it in there? I don't know. Type. Control. Type. Okay, what was that number? 1. Sock stream. Well, if I put socks that did change. I'm not really sure what just happened. Did it undo? They said it doesn't, there's no undo function in here. Word selection. Undefined operand. Okay, yeah, that helped. Now I'm going to say symbolic constant. That's not what I wanted. Undo operand. Undefined operand. What did I say it was? Sock stream. That worked. Now AF. 6. That's 2. F is 2. Okay, find that. Symbolic constant. Yes. Alright, I played around with that. Got some hands-on experience. And then let me see if that's right. 15. The arguments are 6, 1, and 2. Okay. I went a step beyond because, yeah, on the next one, 16, it says look up MSDN page for socket. Make the parameters more meaningful. Symbolic constant, I proto, TCP, and then sock stream, and then AF inet. Okay. 17. Search for usage of the IN instruction opcode 0xED. Search. Next code. Yeah. Search for IN space. This worked for me, but I think there's a way you can do opcode. So they say it only happens in one spot, and this is it. Okay, instruction is used with a magic string to perform VMware detection. Is that in use in this malware? And the fact is yes, because what I did was I looked up this number on the internet. And it came out with how does malware know the difference between such and such. VMware uses the output to communicate. A piece of malware can detect that presence by doing the following. And this relates to VMX here. EBX should have the magic number VX. VMware is present. Okay, what else do we have in this question? Using the cross references to the function that executes the in instruction is a further evidence of VMware detection. Control X. Yeah, it says found. It does a check. It says found virtual machine at install cancel. Okay, now 18. jump your cursor. And we'll go ahead and do that, but I don't have IdaPro commercial, so 19 through 21 I can't do. I have IdaPro free. So we see some stuff, and it apparently is encrypted because in 19 there's this script, and then in the back of the book in the answer you can see that what the script is doing is it's decoding. I guess excuse me, it's not really encrypted, it's encoded. The script grabs the current location of the cursor, loops from 0 to x50, grabs the value of each